Hello students, welcome to another tutorial on vectors. So in this tutorial, we're going to work out the last video that I left you guys with in the previous video. And I hope you guys had time to try it. If you have not yet tried out this question, you just pause the video and attempt it. Now, if you struggle or maybe you didn't see my earlier video, I'll leave a link in the description. You just check it out and then come back to try the question and see how it goes. So basically, this is actually basic, and I hope you guys were able to pull it off. So what they want us to find are the X and Y components of a force A. Now this force A, what do we know about it? All we know is when this force A is added to another vector B, which has magnitude, which has components -10 and 8 in the X and Y directions respectively, we get a resultant whose magnitude is all in the positive X direction, and it has a magnitude 12. Now, what does that mean? To just get a clear picture of what is happening, I always ask my students to just make a table so that we just get a clear picture of these vectors and their components. Now, the table kind of makes it easy for you to manipulate or get the resultant or find how these components are interacting. In this case, we only have two vectors which have to give the resultant. So I label this the vector A and the vector B. And then here we have the resultant. Now, what we have is here we have the X component, and here we have the Y component. So what we want to find now is how do these interact? So in the previous video, we did see that the X component of the resultant is obtained by adding all the X components of the vectors that are interacting. So in this case, we have A in X is here, and then we have B in X is here. And when we add A in X plus B in X, we get R in X. But of course, we only add when we know, or when they say the vector sum, or when they just use the term resultant. So if they don't want you to get a sum, they might say something like A minus B, or maybe B minus A. Then they want you to get the difference of the two vectors. But if they just say resultant of some vectors, then they want you to get the vector sum. And we know we only add vectors in terms of their components. And here, of course, what we have is the Y component of A, and here we have the Y component of B, and what we get here is the Y component of the resultant. Now, of course, just as we saw for the X, for the resultant, to get the Y component of the resultant, we have to add A in Y plus B in Y. Now, what does the question tell us? The question tells us to say B in X is -10. And then B in Y is given to us as 8. So the resultant has magnitude 12, and all of it is in the positive X. There is nothing in the Y axis. So the resultant has a component 0 in the Y axis. So from here now, we see that if we use this equation to get the component that we want, the X component, we see that the X component of the resultant is 12. We want to get AX and then BX. So this is plus -10. So this shows us that we have 12 is equals to AX minus 10. And then from here, when we group the like terms, what we now have is 12 plus 10. When the -10 crosses, becomes positive, is equals to AX. And finally, we have 22 is equals to AX. So this is AX is equals to 22. Now remember, we're dealing with a force. So this is 22 newtons. So if you just want to be systematic, you just even put right on your table, right on top, you can even just put N. Even this side, these components will all have units newtons. So I don't have to repeat those units in the table. Okay, next up, we go to the Y-axis. So to the Y-axis again, the resultant is 0. The resultant component in the Y is 0. A in Y is the one we want to find, but B in Y is given in the question, that is 8, positive 8. So again, we move that 8 to the other side, becomes -8 is equals to AY, implying that AY is equals to -8 newtons. Okay, so the question was asking us to get the components of A And we've got these components. This is the y component of A, and this is the x component of A. So you can just verify that from the question. They want us to find the x and y components of force A. Now, just in case you're wondering how, suppose they wanted you to get now the magnitude of the resultant. So these are just components of the resultant. So if they want you to find the magnitude of the resultant, all you have to do is that magnitude, not with the resultant. If they want you to find the magnitude of A, the magnitude of the vector A from its components, all you have to remember is to get these components or how these components interact. In this case, they're both positive. So what you have is something like this. So this is the XY plane. So what the components imply, I always describe the components as steps that you have to take. So I noticed that the X component is positive. So because the X component is positive, it means that the first step has to be taken to the right. Remember, positive is this side. So let me use black for this side. So this is the positive X axis. Then this is the positive Y axis. So if they wanted us to get the resultant, the first thing that I want you guys to observe is that first step, A in X is positive, so you'd go this side. And then the next step, I look at how the Y axis is, the Y component is, it's -8. So since it is negative, implying that I'm going down. So Y is negative when you're going down. So it would go like this. So that resultant that they want us to get, the vector A itself, it is actually a vector that is starting from this point, from the origin, and then going all the way down. Now, from here, you see that to get this vector A, given A in X and A in Y, so you guys have to recall that Pythagoras theorem finds or gives me that vector, that magnitude A. And how does it, how do I get it? So you guys should be able to recall from the previous video that this will be given by A in X squared plus A in Y squared. But of course, in this video, they didn't add it. In this question, they didn't ask us to find the magnitude of A. They only wanted us to get the components of A, which is 22 newtons and that -8. But I'm just saying, if you wanted to get the magnitude of the vector itself, not the components, the vector, you then use the components in this equation to get the vector itself A. Okay, now the next step that is remaining, if we go back to our question, the second part was asking us to find the angle it makes with the positive X axis. So if I use my diagram just here, so I've already sketched this vector. I've already sketched it. And if you look at it, so I first have my A in X, my X component. That's what I drew first. After that, then I drew my Y component, which was pointing down because it was negative. Now the question is asking me to find the angle this vector makes, the vector itself A makes with the positive X axis. So you can just verify that. Just go to the question and look at it again. It's the angle it makes with the positive X axis. Now, if you look at it, this is the angle. You can look at it from two ways. If you measured it from here, if you can easily get this angle by taking this shape as a triangle. What you'd get is an angle which is here. But remember, angles are always measured from the positive X and they have to be measured anti-clockwise. So the question is actually asking us to find this angle, which is this side. So I'm going to label this angle as theta. So we're going to use tan, trigonometric ratios to get what this phi is. Once we get the phi, you can easily use this phi to get what theta is, which is the angle they want us to find. Now, how do we do that? So of course, if I was just to sketch that triangle again, so what we have is something like this. So this is my A in X, this is my A in Y, and then this is my phi. So we see that the sides I have here, one is the adjacent, the other one is the opposite. So they relate by tan. So I have tan phi is equal to, so tan is opposite AY over the adjacent AX, or phi is equals to tan inverse of AY AX. So from here we can substitute and work out what that phi is. So we have tan inverse of, when we make the substitution, that is -8 over 22. So from here, what we get is that the angle phi is actually -20.0 degrees. Now, this angle, of course, the negative just implies that we are measuring this angle clockwise, which makes sense. If you go back to our diagram, this angle phi is measured from the positive x, and we're going clockwise. That's what the negative implies. But all we're saying is this is 22 degrees. Now, since this is 22 degrees, we can easily calculate that other angle this side, which is the angle that we actually want measured correctly anti-clockwise. So this, of course, you guys should see that we just have to less this 22 from 360, since a full rotation gives us 360. So we're saying if we had phi added with that angle we want, theta, would get 360 degrees, but we only want to find what theta is, meaning we have to subtract from 360 that phi, and we've already seen what phi is. Now, I'm not going to use the negative. The negative just points how the angle was measured. So I won't bring the phi with its negative here. I only say minus 20 degrees. So of course, if you subtract, what you get is 340 degrees. So this is the angle that the vector A makes with the positive x-axis. Okay. Okay, and apologies here, I kind of wrote 22 degrees when we had actually found 20 degrees. Okay, so I can actually write this better. Instead of writing it here, we can just write 5, not theta. We found cos phi is equals to 20 degrees. Okay, and of course, that is the phi. Okay, so that is the angle that they wanted us to find, and we found it. It's the angle the vector A makes with the positive x-axis, measured correctly anti-clockwise from the positive x. All right, so I hope you guys were able to follow. In the next video, we're going to look at another simple question. You guys can actually try it out in advance. I hope you'll be able to work it out. It's not very complicated. Yeah, so you guys can try it out. Otherwise, see you guys in the next video. And this was your tutor.